I did, I was so close on the 5. What you put? 17. Yeah.
There you go.
Yeah.
All right. 1, 2, and 3. Well, here's the deal. If you would have worked the review, how do you know how to do this? It says the sine of theta. Sine is opposite over hypotenuse. Well, here's theta. This is the opposite side. That's the hypotenuse. Man, that's tough. If you wouldn't have known that side, you know what you'd have done? Use the Pythagorean theorem. To find this side, I would have said that 4 squared plus b squared equals 5 squared. So that's 16. That's 25. When I subtract, I get 9. When I take the square root, I get 3. That side's 3. So if you wouldn't have had a side you needed, you'd have used the Pythagorean theorem to find the side that you needed.
So the answer to that was just simply
4/5. Look at number 2. 2 was a little bit harder. 2 says the tangent. Well, what do you give? Look at the angles. Here's your angle. I need the tangent of this. Tangent's opposite over adjacent. There's the opposite side. That's the hypotenuse. What do you not have?
Are we going over our test?
We're going over a version of the test. There were 4 versions of the test, so everybody don't have this one. Here's theta. That's the opposite side. Hypotenuse. This is adjacent. That's blank. So we're probably going to solve for that one. Would make sense. If that's the hypotenuse, this is C. This can be A or B. It doesn't matter. This can be Q. That's 36. When you have one that looks like this, you square both terms. That's 5 squared, which is 25, times the square root of 13 squared, which is 13. Well, yes, ma'am. Multiply those two. Well, guess what? If you don't know what 25 times 13 is, you go on your calculator right here, you hit 25, well, not 22. Times 13, you hit enter and you get 325. So this is 325. That's still 36 plus b squared. And I'm going to subtract. 325 minus 36. You get 289. Take the square root of that. You get 17. So B is 17. So now, here's the opposite side. There's the adjacent side. So guess what the tangent is? The opposite 6 over the adjacent 17. That's all you have to do. You have to make a fraction. Write it down. That's it. Number 3. Says the cosine of theta. Cosine is the adjacent side over the hypotenuse. Do you know the adjacent side of theta? No. There's the opposite. There's the hypotenuse. So 11 squared plus b squared equals 19 squared. That's 121. If you don't know what 19 squared is, go to your calculator. It's 19 squared. You get 361. Then you would subtract 121 from it. You get 240. That probably don't have a true square root. But if it doesn't, you could have said this. You could have said 15.5. I'd have been okay with you saying 15.5. You could have said that B was 15.5. And just wrote it like this. The adjacent side over the hypotenuse. And that would have been sufficient. And that was 1, 2, and 3. Number 1 was a gimme. It had everything you needed. You just had to write it down. Then we got into actual questions that required some type of thinking. Number 4 said find the measure of each side indicated. Round to the nearest 10. Look at the angle. You can use whatever you want to use. Here's your angle, 25. What 2 sides do you have? Well, there's the hypotenuse. So I know it's going to be sine or cosine. Do I have the opposite side or the adjacent side? The one that's across from the box is the hypotenuse. The one that's across from the angle is the opposite. So I have the opposite side and the hypotenuse. So I'm going to use sine. Well, I set this up. It equals the opposite side, x, over the hypotenuse, 11. How do you solve this? I would multiply by the denominator on the right side. That cancels that. You got 11 times the sine of 25. Some people don't know how to put that in your calculator. Here you do. Here's what you do. You say 11 times the sine of 25, close parentheses, hit enter. Well, hold on. It's not in the right mode. It's not in the right mode. Hold on. 11 times the sine of 25, close parentheses, 4.6. So this x, that side, was 4.6. That's all you had to do. There's nothing you had to find. You just had to take what you were given. Number 5. Number 5 says, find the measure of each side indicated. We'll find the x. And that's the side we don't know. Well, you have 51 degrees. So I've got 51. I'm going to look at the sides that I'm given. 11 is what? Well, we know here's the box. X is the hypotenuse. Correct? 11. Is that the opposite side? Well, the opposite side is, if I took this and drew a straight line from my angle, that would be the opposite side. I don't have that one. So it's the adjacent side. So the cosine of 51 equals the adjacent side of 11 over the hypotenuse x. Now, here's the shortcut. If you have x as the denominator, if you have the cosine of some angle equals a number over x, and x is your denominator, these two just swap places. So x equals 11 divided by the cosine of 51. So how do you put that in the calculator? Huh? 11 divided by cosine of 51. Close parentheses. And 17.5. So x 17.5. Questions on this one? This is the only one that's been even remotely difficult because x in the denominator. Anybody understand that when x in the denominator, you have to swap your cosine, your whatever trig function you have in x, just swap them. Number 6. Once again, we're finding this side. I have 74, I have 15, I have x. Well, x is the hypotenuse. If I took this out, I took an arrow and drew it across, I'd do the opposite side, but I don't have that. I have the adjacent side, 15. Well, if I have adjacent and hypotenuse, I'm going to use cosine. So cosine of 74 equals the adjacent side 15 over the hypotenuse x. What happens when I have it like this? What do you swap?
74.5.
Well, you swap cosine of 74, you swap the whole thing. So x equals 15 divided by the cosine of 74. So, once again, put that in your calculator. You've got 15 divided by the cosine of 74, close parentheses, 54.4. So this side over here is 54.4. If you notice, this took me this much work on every question. I wrote down two things. One equation, and I swapped it. Some of them, I didn't even write another step down. I could go from the equation that I had to the answer. Now, 7, 8, 9, we're finding theta. We're finding an angle. It's a little bit different. Not a lot, but a little bit. What two sides do you have? Obviously, we don't have what? The hypotenuse. What's the only trig function that does not use the hypotenuse? Tangent. So I'm going to say the tangent of theta. That equals the opposite side, 15, over the adjacent side, 5.2. I'm looking for theta, I use what? The inverse trig function. Whatever my ratio is. So, in the calculator, the only difference is I hit the second, see the top left button right here? See this button? I hit that one first. Second, I'm going to hit tangent. That brings up tangent to the -1. Everybody see it? And then I'm going to put 15 divided by 5.2. Close parentheses, hit enter. I get 70.8 or 71 degrees. So this theta, 71 degrees. Once again, it's a two-step thing. Write it down, write two steps down. It's not very difficult.
So I don't have hypotenuse, use tangent.
Number 8. In this one, I have the hypotenuse. I also have the opposite side. What uses the opposite and the hypotenuse?
Sine.
cosine. Because now they both use hypotenuse. But sine uses opposite hypotenuse, so I'm going to say the sine of theta equals the opposite side 2 over the hypotenuse 7. Once again, I'm looking for theta. So I use the inverse sine of 2 over 7. Put that in your calculator. I say second sine 2 divided by 7. Close parentheses, hit enter. 17 degrees. So theta, 17 degrees. Questions on this one? On the next one, last one. Here's theta. Well, what do I not have? I don't have the hypotenuse. I do have the opposite side and the adjacent side. Once again, what's the only one that does not use hypotenuse? Tangent. Equals the opposite side 14.8 divided by the adjacent side 7.7. Looking for theta? Use the inverse. Put that in your calculator. So I say inverse tangent of 14.8 divided by 7.7. Close parentheses. 63. So theta in this problem is 63 degrees. Who doesn't understand? If you do not understand, raise your hand. Is that everybody? Everybody understand? Yes, sir.
On the theta,
Yes.
it doesn't matter where it's at, whenever you do, like, for opposite, it's always gonna be across.
It's going to be always going to be across. Opposite's the one. If you find the opposite side, if this was up here, okay, and you drew an arrow straight across, this would be the opposite side of theta. Yes. Here's the deal. I'm about to go print off some more reviews. The only way we drop this test, because we're going to take another test tomorrow on the same stuff, the same exact outline. Now, it will be different numbers, and you're still going to have to work it. But the only way we drop this test is if everybody in this class makes an A. If everybody makes an A, we'll drop this test. If one person doesn't make an A, we're keeping both test grades. That's the only way we drop this test. So we went over every type of problem that anybody could see on this test. There's 3 of each.
If there's something you're not sure about, y'all better speak up now.
Better ask.
Well, can we ask now? About a question?
Do what?
Can we ask for a question now?
If you have one.
Can you do like 4 through 6?
Find it inside.
Yeah.
That's what we just did a minute ago.
For instance, number 5. You go like 1, you go over that 1 more time. That's the one that was
All right.
So you get all through this?
Number 5.
Yeah?
Here's number 5. Once again, we're solving for x. There wasn't even any on here like the review where you had to solve the triangle. There wasn't even any on here like that. Here's the angle, 51. The one directly across from the right angle is always the hypotenuse. So we know we're going to use a trig function where that hypotenuse is used. because x is there. That's the side I want to solve for. The opposite side is the side directly across from the angle. That's not there. So this side 11 has to be what? That's the opposite, because it's directly across from the angle. So this side 11 has to be what? What side is 11?
Jason.
This is the adjacent side. What trig function uses adjacent and hypotenuse?
Tangent.
Nope.
Cosine.
Cosine. So the cosine of our angle, which is 51, equals the adjacent side 11 over the hypotenuse x. What happens when x is in the denominator?
Now I know what to do. We got to swap it.
This swap. Correct? Everybody see that?
Swap the x and the 51.
You swap the x and the cosine of 51. You swap this whole side and that x. So what x equals is 11 divided by the cosine of 51. So when you put that in your calculator, you say 11 divided by the cosine of 51 and hit enter, and you get 17.5. Yes, ma'am.
Do you care to work it the long way for like visual folks like myself?
Yes, ma'am. 17.5.
Just so they know what you mean by swap.
Okay, here's what you do. Instead of swapping, what you could do is multiply both sides by x. And these sides would cancel, right? So you would end up with x times the cosine of 51 equals 11. Now, you got to get x by itself, so I divide by the cosine of 51. Which then cancels that side, and you're left with x equals 11 by the cosine of 51. Does that make sense?
I just didn't get where you found the adjacent.
I can't remember what I can get cosine of. I know, that's why I can't remember what it is. Huh? I know.
That's how I remember.
If you label your pieces with an O, an A, and an H.
When you get an angle, right, like in this problem, here's your angle. So look here. Directly across opposite. Directly across the 90 degree hypotenuse. The one next to it going on this left, adjacent. Now, from this angle, you know the adjacent side, and you want to find the hypotenuse.
Yeah, I know how to do the problem. I just think
Adjacent hypotenuse, so I'm using cosine.
it's just hard for me to.
So then, what you say is the cosine equals the adjacent side over the hypotenuse. The sine equals the opposite side over the hypotenuse. The tangent equals the opposite side over the adjacent side.
So anything on the inside, like the degrees or the theta, that's gonna where you're gonna determine the opposite.
Yes.
And adjacent.
Yes, from your reference angle. Now, this is your reference angle.
That's the main one.
Yes. Any more questions? Any other questions?
So the degree.
What if the X is on top?
If the X is on top, okay. I think there's one like oh, something fine. I think it's
That's
number
number 4.
All right, number 4. Here's the angle. Directly across. Opposite. Now, you have to be careful because here's the right angle. The one directly across from that's the hypotenuse, correct? We don't have the adjacent side. So you're dealing with the opposite side and the hypotenuse. Which one of those deals with opposite and hypotenuse? The sine. So the sine of 25 equals your opposite side x over the hypotenuse 11. Now, this is just like working it the long way here. How would you get rid of this x divided by 11?
X parentheses, sine 25.
Well, no. The only way you get rid of divided by 11 is do the opposite. Multiply by 11.
So
Yeah. So I'm multiplying by 11 on both sides, because that cancels that. Now that whole side, I'm left with X. So I've ended up with 11 times the sine of 25. That equals X. So now I just put that in the calculator. .6. So this X. 4.6. Does that make sense? Does everybody understand? All right, I'm about to print off.
Treasurer, you just letting them print on the machine?
Yeah, I'm gonna send it. I'm gonna just send it down.
I'll run and get them so I was gonna say.
I'll get it. It's fine.
Yeah, you need the exercise. No, I'm just kidding.
I do.
I need it. I would do it.